Hypothalamus Artificial Intelligence, HI, and Research Center for Advanced Decision Technologies, R-CADT, presents the conference. Predictive and Prescriptive Advanced Analytics, Integrating Technologies. Hypothalamus Artificial Intelligence announces to the global community interested in artificial intelligence that, based on the alliance established with IBM and GAMS, HI offers the line of projects and services that integrate predictive artificial intelligence, forecasting, and prescriptive artificial intelligence, optimization. Hypothalamus Artificial Intelligence, HI, is a knowledge-intensive company in advanced and complex mathematical modeling. Its main research focuses on the integration of traditional artificial intelligence, mainly supported by artificial neural nets, ANN, and the machine learning algorithms, based on support vector machines, SVM, with the large-scale mathematical programming principles. This is aimed at producing artificial brains, that is digital transformation driven by autonomous and intelligent algorithms in real time, in accordance with the era of Industry 4.0. HI presents the products offered in its Watson's Gold 100 Partner Business Plan organized with IBM, TD SYNNEX and Peer-to-Peer Global, and with GAMS. The General Algebraic Modeling System, GAMS, is a high-level modeling system for mathematical optimization. It is designed for modeling and solving mathematical programming optimization problems. GAMS is tailored for complex, large-scale modeling applications, and allows you to build large maintainable models that can be adapted quickly to new situations. Models are fully portable from one computer platform to another. The HI-GAMS Alliance is able to solve complex problems by facilitating the diffusion of mathematical programming. International Business Machines Corporation, IBM, is an American multinational technology company headquartered in Armonk, New York. IBM manufactures and markets computer hardware and software, and provides infrastructure, internet hosting and consulting services in a wide range of computing-related areas, from mainframe computers to nanotechnology. IBM holds more patents than any other U.S. technology company and has 12 research labs. Its employees have received 5 Nobel Prizes, 4 Turing Awards, 9 National Medals of Technology, and 5 National Medals of Science. The Watson's Artificial Intelligence System is one of IBM's famous inventions. The TD SYNNEX IoT Solutions Factory is a program designed to drive the creation and delivery of IoT solutions, leveraging the best of the TD SYNNEX technology provider ecosystem. The goal is to equip the community with information about the art of the possible with IoT. This is done by taking IoT concepts and validating these concepts by leveraging the expertise within TD SYNNEX and its partners. Companies don't buy IoT, they buy business outcomes and solutions to real-life challenges. These are proprietary TD SYNNEX solutions, leveraging components from multiple vendors to define the TD SYNNEX architecture. The products are defined by TD SYNNEX in collaboration with the supplier ecosystem for interoperability testing. Peer-to-Peer Global is designed and represents all types of IT solution providers. While many solution providers sell products and services for manufacturers or technology providers, the profiles of companies represented in Peer-to-Peer Global can highlight their specialized capabilities, skills, and unique offerings, regardless of technology providers. Hypothalamus Artificial Intelligence, HI, is a knowledge-intensive company in advanced and complex mathematical modeling. Its main research focuses on the integration of traditional artificial intelligence, mainly supported by artificial neural nets, ANN, and the machine learning algorithms, based on support vector machines, SVM, with the large-scale mathematical programming principles. This is aimed at producing artificial brains, that is digital transformation driven by autonomous and intelligent algorithms in real time, in accordance with the era of Industry 4.0. HI produces 4 main products: Artificial Business Management, Artificial Brains, Enterprise-Wide Optimization Systems, EWOS, and High-Complexity Multi-Problem Mathematical Models. These 4 products make up what could be called artificial intelligence for decision-making or artificial intelligence for the future. OptEx, Optimization Expert System. A decision-making artificial intelligence knowledge factory. HI incorporates its technological platform, OptEx, Optimization Expert System, based on AI to facilitate the generation of highly complex multi-problem optimization models. Hi is the knowledge factory and OptX is the cognitive robot that produces the algorithms of the solutions produced by Hi. OptX is artificial intelligence that produces artificial intelligence. Hi is a knowledge factory and OptX is the cognitive robot, an artificial intelligence, in charge of implementing all the computational aspects of the optimization algorithms, on any commercial platform, without using programmers. This contribution from OptX, Optimization Expert System, is essential for Hi to be a high-productivity mathematical modeling company. Hi is an expert company in the use of IBM technologies marketed as decision optimization, of which C-Plex Optimization Studio stands out. Hi uses solvers implemented by IBM, like C-Plex. Hi is also adept at using GAMS, General Algebraic Modeling System, which may be the first fourth-generation commercial language for mathematical modeling. The two platforms can be integrated if deemed appropriate. This process has made Hypothalamus AI one of the select tech companies that can confidently claim to be an AI knowledge-intensive company. Hi's knowledge covers all advanced analytics, predictive and prescriptive. In an industry, the predictive part may concentrate on the study of demand and other random factors, and the prescriptive part may concentrate on the study of production planning and scheduling. From the point of view of organizational management, it can be said that the demand model and the production and sales model are the hypothalamus of the organization. How these two models are handled is the cornerstone of successful planning. A very good demand forecast, followed by regular production planning, or a regular demand forecast followed by very good production planning, will put the organization at risk. The modeling effort must be done in both directions. Analytics has given rise to two levels of artificial intelligence. Traditional artificial intelligence, supported mainly by neural networks, with a long life of almost 80 years, since its creation in 1943, by Warren McCulloch and Walter Pitts. It is the most well-known and economically successful AI, and its current state-of-the-art is the Generative Pre-trained Transformer, GPT, which is a computer program with impressive capabilities to generate text completely autonomously. Generative Pre-trained Transformers, GPT, are a family of neural network models that uses the transformer architecture and is a key advancement in artificial intelligence, powering generative AI applications such as ChatGPT. GPT models give applications the ability to create human-like text and content, images, music, and more, and answer questions conversationally. Organizations across industries are using GPT models and generative AI for conda, text digesting, content generation, and search bots. Despite the undeniable success of GPT, and the great help it provides in all generative artificial intelligence, its ability to solve decision-making problems is almost nil, because its mathematical essence does not have the foundations for it. This is well known to scientists working on GPT development. Decision-making artificial intelligence is a new term, coined by Hi to refer to optimization algorithms aimed at decision-making. It could be said that its birth coincides with the launch of the ENIAC computer, in 1947, which gives voice to digital iterative algorithms such as the simplex method, created by Danzig. It is very little known, and there are very few companies specialized in this area of knowledge. Hi is one of them. Hi has accumulated 50 years of intellectual property in this field. Therefore, if you want to make the best decisions, you must do so by integrating the two methodologies, generative pre-trained transformers and mathematical programming. This advantage is offered by Hi, which is a top-tier company in mathematical optimization models, and which is prolific in generative artificial intelligence, which allows it to complete high-quality solutions. To bring its methodologies to the solution of companies' problems, Hi uses Watsonx as the artificial intelligence platform produced by IBM, and Decision Optimization, produced by IBM, and OptX produced by Hi, as an integrated decision-making platform. Given the short existence of GPT as a solid methodology that gives rise to many commercial products, before its existence, developers of predictive analytics models generated their own technologies, which in most cases involve the development of specialized solutions based on predictive analytics algorithms associated with real-life problems. This is the case of HI, which for many years has been using optimization platforms, such as GAMS or IBM ODM, to generate predictive and prescriptive optimization models, to integrate them and form the system model. Integration with GAMS. It is geared towards the use of optext to create the algorithms for the two types of artificial intelligence. This approach must give the same results as one based on pre-built algorithms used by the predictive AI modeler. But it is possible to take advantage of the fact that by directly implementing the algorithms, they can be fully adjusted to the real case, without the need to work with algorithms designed by other modelers, which could imply approximations for a specific case. What is the best solution based on many factors that must be considered when specifying a commercial proposal? HI is currently working on the integration of optext quantum AI to generate the programs on a supercomputer, or on a workstation, and solve them in quantum optimization algorithms, encoding the programs in the IBM Qiskit tool. For Hypothalamus Artificial Intelligence, it will be an important achievement to increase the productivity of your company, using the best technologies of the moment, backed by a trained professional team. Thank you very much for your attention. What's the difference? Full truckload shipping versus less-than-truckload. Less-than-truckload, LTL, transport networks. An LTL network consists of the following entities. Load, it is associated with the problem of local collection and delivery, from the loading site to a terminal of the LTL network. It is not considered in the LTL network since it is assumed to be part of another process. End of line, EOL, it is the origin or destination of the cargo. Therefore, for each end of the terminal line it is the hub, center, closest to the loading/unloading site that is considered as the origin or destination of the loads. Break bulk, HUB, terminal where unloading, sorting, and loading from one truck to another is carried out. Hubs connected to a certain primary point are called satellites. Terminal, HUB, terminal where unloading, sorting, and loading from one truck to another is carried out. Hubs connected to a certain primary point are called satellites. Less-than-truckload, LTL, transport networks. Challenge, to develop a DSS to support LTL, less-than-truckload trucking, business of a transport broker. The central problem is to choose the most profitable transport service demands, for direct long-haul routes or for multiple pickup and delivery routes, and fix the offer price for requests for transport services or accepting an offer previously agreed in a long-term agreement. An LTL network is made up of a transport company with a fleet of trucks, which serves a sequence of delivery requests, received either by phone, mail, or internet. Solution: design a DSS for LTL revenue management that must have the following models. ML-like models are used. Demand winning bids determines SVMs, support vector machines, to segment winner bids of prices offers to charge to load generators. Supply winning bids determines SVMs to segment winner bids of prices offers to pay to the transporters, and link LTL network dispatch and revenue management including the SVMs that defines the winning frontiers for price offers. Result: proposal showed to potential client jointly with a business partner to implement the DSS for an LTL operator. The figure features an illustration of the LTL trucking operation network. 12 end of lines, 5 hubs, 36 loads, and 11 trucks. The central problem of an LTL broker is to choose the most cost-effective demands for transport services, direct long-distance routes or multiple pickup and delivery routes, and the fixing of the offer price for requests for transport services or the acceptance of a previously agreed offer in a long-term agreement. An LTL network is formed by a transport company with a fleet of trucks, which attends to a sequence of delivery requests, received by phone, mail or internet. The solution is to implement a DSS for LTL revenue management that must have the following models. Winning price bids to charge for serve load transport generators, determined by machine learning, ML, models to segment the space between winning bids and losing bids. Winning price bids prices payable to carriers, determined by ML models to segment the space between winning bids and losing bids. Link the flow through the LTL network with ML models for revenue management that define the winning frontiers for pricing offers. The figure presents the environment of an LTL broker. On the left side are presented the demands that must, or can, be met, and the demands satisfied. On the right side, the available trucks and the capacities used are presented. The central problem of an LTL broker is to choose the most cost-effective demands for transport services, direct long-distance routes or multiple pickup and delivery routes, and the fixing of the offer price for requests for transport services or the acceptance of a previously agreed offer, in a long-term agreement. An LTL network is formed by a transport company with a fleet of trucks, which attends to a sequence of delivery requests, received by phone, mail or internet. The solution is to implement a DSS for LTL revenue management that must have the following models. Winning price bids to charge for serve load transport generators, determined by machine learning, ML, models to segment the space between winning bids and losing bids. Winning price bids prices payable to carriers, determined by ML models to segment the space between winning bids and losing bids. Link the flow through the LTL network with ML models for revenue management that define the winning frontiers for pricing offers. The diagram on the left shows the trips of the trucks, red, while the one on the right shows the differentiated trips loaded, blue, and unloaded, green. To be solid, the decision-making process implies that when selecting an RS request in an OLH, the broker must analyze what could happen in the following OLHs, simulating what is the decision in the next destination that will happen. This would be called multi-stage decision, which extends the pricing model from a single route to multiple routes. Therefore, the transport problem involves multiple trips, with allocation of quantities and routes, that represent the requests. From the allocation, travel costs and expected benefits are determined. Restrictions such as receipt and dispatch service windows, time windows, arrival time of vehicles in travel, restrictions on LTL applications according to vehicle type, simultaneous analysis of transactions in multiple hubs, OLH, and analysis of collaboration between participants. Therefore, a model to participate in the LTL market must be large-scale and will be based on fundamental models such as VRP, Vehicle Routing Problem, and TSP, Travel Salesman Problem, including variations according to the state-of-the-art and representative modeling of the real world, for example, dynamic travel times dependent on departure time. One of the foundations of machine learning, ML, are the support vector machines, SVM, that have their origin in the works on the theory of statistical learning introduced in the 90s by Vapnik and his collaborators. Although SVMs were originally intended to solve binary classification problems, they are currently used to solve other types of problems, regression, clustering, multi-classification. Since their introduction, SVMs have been gaining well-deserved recognition thanks to their solid theoretical foundations. Next, we will analyze the case of using SVM to support the broker's decisions that require characterizing and/or discriminating successful offers. The business was given, from unsuccessful ones, which implies segmenting the offers between success and non-success. The problem from the SVM point of view is to separate the space by a hyperplane that divides the offers between success and non-success. In this case, the methodology of the support vector machines divides the multidimensional space into two parts, success and non-success. The broker's offers, whether buying or selling, are stored in a database. If the offer is for purchase, for example, how much to pay for the rental of a truck, to serve a customer who requests a service characterized by weight, volume, route, type of load, and other parameters. The database can store data from the broker, as well as from competitors. The result of processing the database will be the price to be offered for rent the truck. Based on the natural mental model, the buyer will try to offer the lowest possible price, which gives them the opportunity to win the business while also maximizing its revenue. However, if the price falls to zero, the broker will not make a profit, and if it stays too high, the chance of winning the purchase decreases. Using SVM, the broker can set the maximum price limit that produces winning bids, and using an operating model, which simulates the process of using the truck, set the minimum price limit to have a profitable bid. In this price range is the solution for the price. The problem with SVM is to select from an infinity of possibilities, the one that is considered the best to divide the multidimensional space. Any of the group of methodologies based on the concept of SVM, select a hyperplane to divide the space in such a way that each point of the sample is on one of the two sides. The methodology to be used may vary with the type of problem. There are infinite numbers of hyperplanes that can separate, segment, winning bids from losing ones. SVM allows to determine the optimal hyperplane as one that maximizes the distance from the closest point of each group to the support hyperplane, vector. Generalized Support Vector Machines, GSVM, is an extension of SVM that enables segmentation problems that are not limited to linear relationships. The problem to be solved is presented in the image, where K represents the function of the kernel K. Until now, the idea has been assumed that the sample objects were separable or quasi-separable, and therefore hyperplanes were defined as linear functions in the space of objects. Now, we describe how to use nonlinear base function sets to define high-dimensional transformation spaces, and how to obtain optimal separation hyperplanes in such transform spaces, which are called feature space, to differentiate it from the space of input objects. To do this, the original mathematical characteristics of objects must be converted into transformed features based on one or more kernel functions, kx, which can lead to expanding the number of features to be considered in objects. The model maximizes the expected value of the broker's profits for all trips originating from any node in the LTL network. The decision to make an offer, or not, is a subjective process in which there can be multiple criteria. The rule is bid only if the offer is classified as successful. Conceptually, it must have the following models: SVM DEM, SVM OFF, winning bids, ML model that determines SVMs to segment chargeable prices to load generators. SVM OFF, winning bids, ML model that determines SVMs to segment payable prices to carriers. MaxRM, dispatch of the LTL network and revenue management, contains the dispatch model of the LTL network and its link with the income of the broker. The diagram presents the connectivity of the three mathematical models. The SVM models feed the MaxRM model that simulates the operation of the transportation network, determining the balance between supply and demand, and optimizing profitability. The results are: prices purchase transportation services, prices sale transportation services. By separating the forecasting pricing models into two machine learning models, based on SVM and integrated with the revenue management optimization model, it is easy to integrate the three models into a common technology platform using GAMS and CPlex, and leverage Optex, Optimization Expert System, to make all three models. MaxRM maximizes the expected value of the broker's profits. The decision to make or not to make an offer and determine its value is not a subjective process in which there can be multiple criteria. As a condition of the business, a rule is included that limits offers to those that are classified as successful. The constraints of the MaxRM model are grouped as follows: revenue, equations representing revenue and operational expenditures. Travel assignment, restrictions on vehicle capacity and service assignment to vehicles, corresponds to the system of equations WXR equals 0. Offer sale, restrictions of coordination of the offers of sale of services, correspond to the equations that coordinate the offers with the equations WXR equals 0. Purchase offer, coordination restrictions of service purchase offers, correspond to the equations that coordinate the offers with the equations WXR equals 0. DEM support hyperplane, SVM, DEM of the sale price, corresponds to the equations SVM DEM, X, R. Off support hyperplane, SVM, off of the sale price, corresponds to the equations SVM off, X, R. Other restrictions, business rules. The image presents the reduced formulation of the problem. Like Herbert Simon, Hypothalamus Artificial Intelligence believes that computer-based mathematical modeling is the greatest invention of all time. Thank you for your attention.